Hi everybody, and welcome to another part of the Solidity tutorials. In this part we're going to create another kind of contract which is related to ERC20 smart contracts. And as you can remember, we said that we can customize the ERC20 tokens in a way that we can set their own prices and, for example, create a kind of a stable coin or non-stable coin, and also be able to determine how the price increase or decrease. In this part, we're going to get started with that kind of smart contract and talk a little about how the pricing works. So first of all, you need to get familiar with the concept called bonding curve, and bonding curve is a curve that determines how the price goes up with the supply of an asset. So here it's been explained on the CoinMarketCap, and you can read about it throughout the web. And this is a kind of a curve. For example, if I switch to the images here by searching the bonding curvature or curve, here there are two curves. So if I do that, in the images you will be able to see there are different curvatures about the price. The normal, one of the most normal ones is the linear pattern, but here, as you can see, there are different kinds of patterns and different formulas. So it could be parabolic, hyperbolic, and other different kinds of curvatures. Here we're going to create a kind of a smart contract which is somehow like this. So it's parabolic, and so we're going to work on the smart contract which sets the price of the token that has been minted with the OpenZeppelin, and creates a base price, and then after that, by purchasing more and more tokens, the price will increase with a certain formula. So we're going to set that kind of formula and then set the price accordingly, so that once the user, each of the addresses buy some token, the price increases, and once they sell the tokens, the price decreases. So now let's get back to the Remix IDE and create our smart contract. So just as always, let's create a new file. I'm gonna call this bondingcurve.sol, bondingcurve.sol, and notice that this is a creation of a token that follows the bonding curve kind of pricing system. So just as always, I'm going to copy and paste the first two lines, the license and the version of Solidity. So let's do that quickly, and now let's create a contract. So we're going to create a contract, and before we do that, we need to also import the OpenZeppelin ERC20.sol. So here we had the address short ERC20, and I'm gonna copy and paste this import of the library. So here we go. So that's it for the import, and now let's create a contract. So here we go, it's the contract. I'm gonna call this contract bonding curve token. So because this is an ERC20.sol token, we'll call this is ERC20. So this is how we write this, because we're using this library. And then we'll open the bracket. So first of all, imagine that we have a kind of a formula which is, for example, A equals to, for example, B, or so the price should be something like, for example, X and or Y. And imagine that we have B as the constant price, as the first price, the fixed price that we begin with, and then we'll have this formula which is A to the power of 2, A to the power of 2, and this is how we determine the price. So it's kind of a parabolic function, which this is the amount of supply token. A is the amount of supply token, and actually A here is the coefficient, x is the amount of supply. So at first we have zero supply, and then once the user buys a token, then the tokens will be minted, and then we'll enter the price here, then y will be the price of the token. So x is the total supply and y is the price. So now we're going to set the a and b coefficients, so a coefficient and b as a fixed price. So first of all, uint 256 constant a, uint 256 constant a. So constant variables in solidity will be determined this way, declared this way. So a is equal to 1, and also uint 256 public constant. So actually for the previous one we can also set it to public because we're going to use it. Constant b equals to 100, for example. So this is the fixed price at the beginning, and a here is so this is a linear pattern using which we will see our price grow. So this is not parabolic. We can also set it to parabolic if we want to. If we want it to be parabolic, not linear, we can set it to 2. So if we want it to be cubic, 3, and so on. So here let's start with 1 because we want it to be a linear pattern. And then here we can set uint 256 cumulative purchase amount, cumulative purchase amount. This could also be named total supply because or supply, because our supply changes, and this is a number that will increase according to the purchase amount. So no matter what you name it, for simplicity I can call this supply, but don't mix it up with the total supply that we had earlier, because this one is a bit different, and the amount of the supply will change, but the total supply will never change. So that is the supply, and so we've got a mapping here, mapping from the address to the uint 256, and that is the balances, uint 256 public balances, and then we'll have a constructor for the name of the token and its symbol. So constructor string memory name, and also string memory symbol. So for this constructor, we'll have the ERC20 name and symbol, ERC20, we will get the name and symbol, open close the brackets. So that's it. This is the constructor that we usually use for entering the name and the symbol at the time of the deployment of the contract. Now let's write our first function. So function, and this is for buying the tokens. So buy tokens. So we'll get null parameter, and it's a public payable function, public payable function, and now let's open and close the bracket. So we'll require that, so the first requirement is that the message.value will be greater than the current price of the token. So which means that the number that the person who wants to buy enters as the amount of ether that he or she wants to spend should be at least the price of one of the tokens, right? So the person should at least buy one token if he or she wants to buy tokens. There are times that, for example, you can consider some kind of part of the token. So for example, a person can buy half of the token at least, or 0.1, 10% of the token at least. So that is totally up to you how you want to set it. But for now, in this smart contract, we're going to set it in a way that it is just at least one token. So the message value should be greater than or equal to the get current price. So we'll have a function get current price. Right now we don't have it, but don't worry, we'll write it later. And this function will determine the current price of the token based on the number of purchases and how many people have bought the token. So this is the function that follows the curvature related to the binding curve. And otherwise, if the value is not sufficient, we'll write insufficient funds. And then you should at least buy one token. You should at least you should buy at least one token. And then we'll have uint256 token amount. Uint. So actually here the person enters the amount of ether that he or she wants to spend to buy tokens. You can also set it in a way that he or she wants to buy some tokens, and here you determine the number of tokens, but here we want to first determine how much he or she wants to spend in Ethereum, and then we will determine the number of tokens. So here we will determine the number of tokens that he or she will get. So uint256 token amount, token uint256 token amount, and this will be equal to calculate token amount. So this will be another function, calculate token amount, and it will get the message.value. So we'll mint the token for that user who wants to purchase the token. So the mint function will get the message.sender and also token amount. So we'll mint the number of tokens accordingly, and then we will change the balances of the message sender to the token amount. So here we declared this mapping for the address to the balances. So this is the address of the message sender, and this is the balances of that specific person. So this is a kind of an array for each one of the users who wants to buy or sell tokens. So we will have the balances of the message sender, msg.sender, plus equal to the token amount. Here we go. And we'll have cumulative purchase amounts, or here we have, because we have this supply, we'll say that supply plus equal to the message.value. And by the way, you might say that, okay, the person enters some kind of value which might be greater than one token but less than two tokens. Where does this amount go? So the more correct way to fix this is to actually say that the message.sender, so here we should say the spent amount. So uint256 spent amount will be equal to msg.value minus the token amount multiplied by the get current price and then what happens is that we will actually actually increase the supply amount by the spent amount. So this is more accurate way in order to set the supply, and this will much better determine the raise of the price of the token, right? So that's it. And now let's write, we have a number of other functions which we'll write in the future tutorials, in the future videos. So that's it for this part of the tutorial. Until the next one, goodbye.